Hi everyone. In this video, we're going to look at rational expressions, simplifying and the idea of equivalent rational expressions. So it's like with numerical fractions when we're simplifying, what we are doing is we're looking for common factors in the numerator and denominator. So if we look here at this example of 18 over 63, if I consider that 18 can be written as 9 times 2 and 63 as 9 times 7, then I can clearly see that there is a common factor of 9, which means that this fraction simplifies to 2/7. So that's essentially the same principle once I have variables. I'm looking for common factors, which means I need to factor. So in this first example, if I look at that numerator, there is a common factor of 9x cubed. And once I factor that out, I have 2x minus 5. And in the denominator, well, 63x to the power of 5 can be factored in a number of different ways, but specifically here, because I had 9x cubed in the numerator, and I do have 9x cubed as a factor of the denominator, I'm going to write this as 9x cubed times 7x squared. Now I can see that I have this common factor of 9x cubed. It's actually several common factors, common factor of 3 or a common factor of x or a common factor of 9. But the greatest common factor is 9x cubed, and that all cancels out, leaving me with a numerator of 2x minus 5 and a denominator of 7x squared. Important to note that while the denominator here is 7 times x squared, so I could think of it as a factor of 7, a factor of x, another factor of x, this numerator 2x minus 5 is all one factor. It is one entire thing that can't be separated for canceling. We can only cancel entire factors. So even though, for example, there's an x in the numerator and in the denominator, they do not cancel. That is not a common factor of x. The other thing that's a little bit different when I'm dealing with algebraic fractions as opposed to numerical fractions goes back to what we talked about with rational functions. We have non-permissible values. We have restrictions on the value of x. And in this case, given what the denominator is, that restriction is x cannot equal 0. If I look at this next example, it doesn't immediately look like I have common factors. I just said if I have, something like x minus 5, that is a single factor, and 5 minus x is also a single factor, they can't be canceled because they are entire things with that subtraction in there. However, I can factor out a -1 from either one of these. Doesn't really matter which one. I'll go for the denominator. So in the numerator, I have x minus 5, and in the denominator, I have negative x minus 5 when I factor out -1. So I actually now do have a common factor of x minus 5 in both the numerator and the denominator. Now, when I divide x minus 5 by x minus 5, I get 1, although I do have a negative here, so it is -1. So this seems to no longer be algebraic. It's just a number. However, I still do have a restriction because that canceling isn't really an operation. It's division. And that division never could have happened if x were equal to 5. So I still have the restriction that x cannot equal 5. Even though the factor cancels out, the non-permissible value still sticks around. We can also use that idea to write equivalent fractions. So if we look here at this expression x plus 3 over 7x, that can't be simplified. That is already as simple as it gets. X plus 3 is a single factor that can't be broken up, and 7 and x are not common to the numerator and the denominator. But what I've asked you to do here is find an expression that's equivalent to that fraction with the restrictions that are given. So if I look at x plus 3 over 7x, there is already a restriction that x can't be 0. Because if I multiplied 7 times 0, I would get a denominator of 0, obviously not possible. But I need to introduce factors that will introduce these new restrictions of plus and minus 2. So in order to have a restriction of positive 2, I would have to have a factor of x minus 2. And in order to have a restriction of negative 2, I would have to have a factor of x plus 2, because positive 2 and negative 2 would make these factors 0 respectively. But if I've multiplied the denominator by those two factors, then I have to multiply the numerator by the same two factors. So this rational expression, x plus 3 times x minus 2 times x plus 2 all over 7x times x minus 2 times x plus 2, is not a simplified rational expression, but it is equivalent to the original expression I gave you, and it now has the 3 restrictions that are required. There's no point in bothering to distribute all this out. We'll just leave it in its factored form, but this expression meets the criteria given.